Here's a quick example of Riemann sums. So we're going to use some Riemann sums to calculate the area underneath this on this interval with n equals 6. I'll make a quick sketch. You don't need to do the sketch, but it helps. 1 over x, of course, looks like this. Got 1, 2, 3, 4, roughly. So what we're looking for is this area right here. We want to estimate the area from 1 to 4 of 1 over x dx. And the way we're going to do that is we're going to use with n equals 6. I'm going to sort of belabor this with notation rather than just kind of grind through the calculation. I'll let you do the calculation. We're going to use n equals 6. We didn't choose, so we have 1, 2, 3, 4, 5, 6 subintervals. So if n equals 6 means that delta x, quick calculation, 4 minus 1 over 6 is 1/2. That doesn't make sense. Stop the video, pause it, and solve it for yourself. So delta x is 1/2. So we want this area is going to be approximately equal to, let's take the first one. I'm going to use right endpoints. Do this rectangle, which is f of 1.5 times 0.5 plus this rectangle, f of 2 times 0.5 plus, I'm going to run out of space here, I'll do one more. This next rectangle, f of 2.5 times 0.5 plus and our very last rectangle on this interval is the f of 4 times 0.5. I'll let you kind of grind through that calculation. I'm going to just rewrite it a couple different ways. So this is equal to, I'm going to factor out a 0.5 out of all of this, times f of 1.5 plus the f of 2 plus the f of 2.5, so forth up to the f of 4. Again, there's no reason to rewrite this other than kind of to, sorry, I'm kind of right at the edge of the screen there. Just a little delta x. I get this precariously balanced. I'll try to pull it back in here. Other than to illustrate the notation, we can compute this number at any line here. So this is going to be the same thing as, I've got 6 terms. I'm going to write it in summation notation. I've got 1, and take a second and see if you can cast this into summation notation for yourself. 1 to 6, because I got 6 terms, and I've got on each term I have the f of 1 plus at each point k 0.5s, and each one's multiplied by 0.5. This might help to illustrate the Riemann. Whoa! All right, I'm doing this at home. The kitchen table, which is red. You may have noticed. So there's our sort of our summation notation of it. So what we can say is, and I'll let you calculate that number. We can say that the definite integral from 1 to 4 of 1 over x dx is approximately equal to this sum. K equals 1 to 6th f of 1 plus k times 0.5 times 0.5. It's a little unwieldy, this Riemann sum business. computationally, what's the word? Cumbersome? Sure. If we wanted to do n is equal to 20, whew, that would be a bummer. Doable. Just requires patience, bookkeeping, paper, and probably a calculator.